The date was November 22nd, 1959. The place, Renton Municipal Airport, Renton, Washington. The airplane was the first of the Boeing 720s, an intermediate-range jetliner. To the casual observer, it might have been another Boeing 707, a little smaller perhaps. Sharp eyes would have spotted certain differences in the wing, but most of the external wing structure was the same as that of the 707. The big differences in this new jet airliner would be in performance and in economy. At this point in time, the 720 was being taxi tested, but in other important respects, this jet had been flying for quite a long time. In wind tunnel flights, for example, such as this one. Here, scale model testing of hundreds of different weight combinations had proved the soundness of the 720's structural redesign. A weight reduction program to develop a smaller, more agile airframe, many thousands of pounds lighter than the longer-range 707s. This was to be a new species of jet transport for the intermediate range. The 720 had also been flying wherever the famous 707s had flown, to the distant corners of the globe. Paris. Rome. Much of the 720's structure would be the same as the 707's. Most of the systems, equipment, service, operations, the same. And to passengers, there would be no difference. In a very real sense, most of the 720 had already been setting new records for reliability and popularity around the world. In Tokyo. In Honolulu. In Rio de Janeiro. And across the United States. New York. Chicago. St. Louis. Flying to and from every major city, over 1 million 707 passengers had already given a good indication of the enthusiastic acceptance which the new 720 might expect. The long-range 707s had daily carried record numbers of air travelers. The average load factor, a fantastic 90%. And Boeing was now proposing to bring this new style of speed and comfort to intermediate range routes with the 720. Here a landing at Stapleton Airport in Denver. This airfield was soon to become the site of an exciting demonstration flight to prove out two of the 720's important differences from longer-range 707s such as this one. First at Boeing's Experimental Flight Center in Seattle, the unique 707 prototype, America's first jetliner, was fitted out with a new piece of flight equipment, a leading-edge extension. In 720 wind tunnel testing, this thicker, more sharply swept back edge of wing surface between the inboard engine and the body had proved to be superior to other devices for increasing cruising speed and staving off the inevitable high-speed drag rise. This was to be the acid test. Flying since 1954, this prophetic airplane, the 707 prototype, had given birth to a jet family with a promise of spanning at least 2 decades of aviation. With the first 2 of its commercial offspring already flying, the prototype now prepared the way for a swifter and smaller swept-wing descendant, the 720. On the morning of April 11th, 1959, the ancestor of all the Boeing jet transports again made aviation history. Taking off from Boeing Field and climbing quickly to cruising altitude, the prototype eagerly tested its new wings and soon passed Mach 0.9, 9/10 of the speed of sound. Flying at ground speeds up to 630 miles per hour, the prototype arrived in Denver less than 2 hours after leaving Seattle, a new record for the trip. Then another demonstration of 720 design refinements. The operations crew adjusted prototype 720 leading edge flaps. Like the single segment of flap on the 707s, these extended flaps, spanning the full leading edge of the 720's wing, would retract cleanly into the wing after supplying more lift for shorter takeoffs and landings. Another product of Boeing wind tunnel research was about to be demonstrated in flight. The takeoff run, altitude 1 mile above sea level, temperature 35 degrees, gross weight 146,000 pounds. At 3,400 feet down the runway, the 707 prototype, aided by the 720 full-span leading-edge flaps, was airborne. Another takeoff, gross weight 132,000 pounds. This time the prototype required only 2,800 feet. Impressive evidence that the new 720 would not only be swifter in flight, but able to get on and off the shorter runways of many more airfields, an important consideration for the intermediate range, for it seemed evident now that the airplane which could offer the fastest schedules to the greatest number of cities would be the one to attract today's jet-minded flying public. Then after taking on fuel, a high gross weight takeoff, 179,000 pounds of airplane, picking up speed and off the ground in just 5,700 feet of runway, in one of the country's highest altitude airfields. Demonstration concluded. Mission accomplished. The prototype headed back to Seattle. At the Boeing Transport Division in Renton, Washington, work in the production of 720s was already well underway. A full-scale 720 mock-up, a simulated section of the airplane's interior, was fitted out as it would actually appear. The 720 interior, it would offer the identical standard of luxury which passengers had come to expect in long-range flights aboard 707s. A major point of 720 passenger appeal, the unequaled spaciousness and comfort of 4 and 5 abreast seating in full 707 size dimensions. And though shorter than its sister 707s, the new 720 would be able to grow in seating capacity from 80 passengers at 4 abreast to 150 at 6 abreast. A tremendous new earning potential for high-density short to medium-range routes. Fully assembled now, the bare metal was ready to come brilliantly to life. Into the paint hangar went the first Boeing 720. On the morning of November 5th, 1959, the 720 in proud new colors first saw the light of day. It was towed across the factory apron and the shores of Lake Washington and toward the pre-flight area of Renton Municipal Airport, where it would join its sister ships, the 707s, for final adjustments and calibrations. Saturday, November 21st, 1959, the last engine run-ups checked out. The 720 was approved for taxi testing. Sunday, November 22nd, 1959, for the first time the new intermediate-range jetliner moved under its own power. Taxi tests were successful. The airplane was now ready and eager to fly. Monday, November 23rd, 1959. 2 weeks ahead of schedule, Boeing's Chief of Flight Test, Tex Johnston, arrived to take the 720 aloft on its maiden flight. 61 minutes after the first takeoff, the 720 came in for a landing at Seattle's Boeing Field, the conclusion of a satisfactory first flight. The airplane was now turned over to Boeing's experimental flight test staff. At the Flight Center hangar, yet another aerodynamic advance was incorporated in the 720. A 3-foot extension of the vertical fin was fitted. This new and distinctive tall tail would give pilots a finer control of the airplane at low speeds. Another good example of the Boeing engineering philosophy of offering the most advanced design features in combination with the most proven airframe. The airplane was now ready to meet the challenge which confronts every new type of aircraft. Before it could enter service, it had to first prove itself in rigorous and thorough testing, structurally, aerodynamically, each new system, each new control surface. Before passengers could pronounce their approval of this new mode of intermediate range transportation, the 720 had to demonstrate that it fully measured up to its predicted performance, economy, and reliability. It had to justify the faith of its builders. It had to prove its worth. To the men who designed it, to the men who would fly it, and to the Federal Aviation Agency. On March 21st, 1960, the 720 flew to Edwards Air Force Base in the California desert to begin several weeks of certification testing. The mission in this part of certification, RTOs, refuse takeoffs, to determine the field length necessary for the 720 to either abort its takeoff run or lift to a safe height above the runway in the unlikely event of an engine failure after reaching takeoff speed. This would be a critical test of the 720's newly designed main landing gear, and it would serve as proof to the Federal Aviation Agency that the 720's predicted short field lengths were indeed within the safe limits of this new jetliner's capabilities. Here, test 15-18, one of the lower energy absorption stops. Gross weight, 187,000 pounds. At takeoff rotation speed, one engine was cut, the signal to stop, and stop fast. Immediately, 12 million foot-pounds of energy were absorbed as the 720, thundering down the field, braked to a complete halt in a distance of 2,100 feet. After taxiing off the runway, FAA and Boeing men held an informal discussion of the 720's performance. The result? Test 15-18 was an unqualified success. A more rugged test of the 720's braking abilities was test 15-13, a high-energy refuse takeoff. 22 million foot-pounds of energy to be absorbed in braking, part of certification testing for advanced models of the 720, not even on the production line at this point in time. At the FAA pilot's signal, the run started. With a 10-knot tailwind, rotation speed was reached quickly. The FAA pilot cut the first engine, and the flight crew went into action to bring the 720, loaded to a weight of 225,000 pounds, to a dead stop in just 3,400 feet of runway. In a brutal test, the 720 had given an account of itself well within its design performance limits. On April 4th, 1960, the 720 left Edwards Air Force Base, one part of its testing over. More testing still lay ahead of it before its certification in mid-1960. In each and every new part of this airplane, it would be tried to its limits to demonstrate beyond a doubt its complete airworthiness. In a few more days, another production 720 would join this one in running off the many hours and miles of routine function and reliability testing. And through it all, the 720 would fly with the sweep and style of its swift new wings, with the buoyant confidence of its quicker, lighter frame. The 720 would enter service with over 100 orders for it already in effect, and many more, hundreds in the offing. It would go on to become the new criterion of intermediate range commercial aviation. For the airlines which would operate it, it would build new profits, create fast new schedules, bring the jet age to more and smaller airfields. For the passengers who would fly in it, it would draw the many cities of the earth still closer together, set new standards of luxury, comfort, speed, and safety. And for its builders, this newest of the new Boeing jets would become another proud milestone in a long and proud history. This was the beginning of the 720 story.